I've built a crazy flying machine. It's essentially just a motor that's spin stabilised. Today, I'm not going to mess around. Let's just move straight on to me building this thing. Now it's time to put this battery inside the tube. My finger's stuck. So the issue with this design is it's going to be very heavy on one side. It's going to always go like this, like that, right? So somehow I have to stabilise it. You might be wondering, why did I add those 3 flaps of foam board to the side of the bottle? I think the best analogy here is a paper helicopter. You know, one of those paper helicopters where you hold it up in the air, you drop it, it falls, it spins and it lands. When the motor spins up, the bottle will start to rotate in the opposite direction when I let go, due to the conservation of angular momentum. And when it spins, these flaps will be pushed outwards, and in theory should create a helicopter effect, which should help keep it in the air. So the weather has gone from it being too hot to do anything to being too wet for me to do my electronics outside. So I'm going to have to fly my stuff in here. So I need to connect the battery. But because of the way I've done this, connecting the battery is really hard. I have to thread the wire in through here and stick your left hand up in here and kind of wiggle around until it clicks into place. Well, those beeps weren't healthy, but it looks like it's working, so let's try and fly it. The trouble is with this is it can produce enough lift due to pressure. It can produce enough upwards force due to the pressure build up in here to get itself off the ground to about here. But it's incredibly unstable because the battery is displaced to one side. And it can't produce enough thrust to go any higher than about this. So I don't think this design is ever going to fly. When the motor is housed inside the bottle, it produces less thrust. But why? The answer to this is that normally when the EDF is in the air, the airflow out the back that's going down through the motor, it drags air around that's surrounding the motor with it on the outside. So you have a higher mass of air flowing out the back. But when you contain it in a bottle, it can't drag this air with it, which is reducing the thrust. So to fix this, what I need to do is put the motor on the bottom so that most of the air can drag air to increase this thrust. So what I want to do is I want to cut just below the motor here to make a ring going around. For the new design, I've opted to have a single piece of foam board going through the centre, as firstly, this can provide a good mount for the battery and receiver unit inside, so that it's directly above the motor, so that there's no kind of thrust vectoring kind of issues. And also it will stop the bottle from spinning too fast because it will create drag as it starts to spin, and that should also help increase the thrust. It's quite unstable. That worked really well. Oh, why did you jump? Stop.
That wasn't exactly a soft landing, was it?
And that was the end of this one. So after that last landing, the wings took a bit of a beating and the battery is hanging on by a thread. But I think I proved that this can fly, so that's all good. Okay, so that should be recording. Good, right. So based on the previous design where it went spinning up in the air, I'm actually going to use this to fix the plane. So I made this section out of another old bottle, and I've got the air intakes here and here and here, and I'm going to stick this motor inside like this, well, not quite like that, threading the ESC through it like that, and it's going to be pushed on here and shoved on the back of the plane to hopefully provide the thrust I need. So here is the motor connected to the back of the plane. I've got it as straight as I can so that it should thrust in line with the centre of mass of the plane. Because the reason why the previous version kept pitching over like this is because the motor was pushing, is creating a moment around the centre of mass, right? But this should push straight through it so there will be no net moment. It's going to be very back heavy, so I'm going to have to move the battery right to the front to counter the weight of the motor sitting at the back. But hopefully this should fly quite well. So I'm just going to quickly test the voltage of this battery before I put it inside to see whether I need to charge it. So it's reading at 11.53 volts. Really it should be reading about 12.6 if it was fully charged. So I think I'm going to charge it before I put it inside the plane.
See the wing? Do you see the wing break then?
See, it does the same thing again.
Because it's not going to change each time, is it? Because what it's doing is it's pitching up and then stalling and then falling out of the air. So I need to fix that somehow.
Right, I'm about to show you what I did to my plane to shift the centre of mass forwards. Because as I was editing this video, I realised I hadn't done that. So here is the modified plane with the centre of mass shifted forwards. Before, it was about here. Now it's about here, which should make it fly better. I moved the battery forward about an inch, half an inch, and I've added a ring of screws to the front of the nose cone to make it nose heavy. Yes! That is what it's meant to do.
So I've just added the steering fin to the top of this, so hopefully now I can have a bit of yaw control.